Okay, so I think I got most of the screen. Okay, so this video will be in reference to solving time constants in a capacitive DC circuit. Okay, so here I have 24 volts DC source. I have a capacitor that's in series with a resistor, and I want to know what the value of voltage is going to be across the capacitor after 3 time constants. Okay, so initially when you energize a circuit that has a capacitor in it, the voltage charge across the plates will be minimal and the amount of current flowing will be maximum. And that will be the case until 5 time constants have passed. And then you would see your current at minimum, and then the source voltage would be then effectively across your capacitor. Okay, so just kind of a recap. With DC voltage applied to a capacitor, the initial current is very high and it is only limited by the resistance of the circuit. As the charge builds on the plates, the voltage rises till it reaches supply voltage and current is near zero. It takes 5 time constants for voltage to reach maximum value. So after 5 time constants, the voltage across the capacitor will equal the source. Okay. During each time constant, the capacitor voltage increases by the magic 63.2% of the difference between the maximum value and the present value. So we're going to use the same formula that we did for inductors, and we're going to look at it in the regard of an exponential growth, okay, in reference to the value of voltage. So the amount of voltage will be minimal, and then until it's fully charged. Okay, so that's what we're going to be looking at here. So when a capacitor is charging, it takes the same time for the capacitor current to decrease to zero. Okay, the capacitor current decreased by 63% of the present value per time constant. So we're going to look at it in the sense of an exponential growth. So it takes 5 time constants for full charge to be across a capacitor. You could look at it from the discharge path as well. It takes 5 time constants for the charge to be drained off of a capacitor, and that would be exponential decay. Okay, so this particular example, it says, what is the value of voltage across the capacitor after 3 time constants? So the most value increase you're going to see is across that first time constant, just like with your inductive circuit, right? So 63.2%. So let's just look at that from a formula standpoint. So V1T, so the voltage across the capacitor, or the amount of voltage charged across the capacitor after 1 time constant, equals Vmax times 63.2%. Okay, so our Vmax is our supply, so 24 volts DC times 63.2%, and that tells me after the first time constant, I will have a value of voltage across my charge across my capacitor of 15.168 volts. Okay, so it wants to know how much value of voltage charged across the capacitor after 3 time constants. So now we're going to move on to the second, V2T. Okay, so this is the formula. So V1T minus Vmax, subtract V1T times 63.2%. So it's exactly the same way as we did our inductor, except we're talking about the amount of charge across the capacitor. So we've got 15.168 volts, subtract, and then in our brackets, we got our 24 volts DC minus 15.168 volts times 63.2%. So bed mass we have to adhere to our bed mass. So inside the brackets, it's going to be, what does that work out to be? 8.832. Okay, and then you have to apply the 63.2% to the bracket first, right? And that would give you 5.582. And then That's supposed to be an addition here, not a subtraction. Okay, and then I add that 15.168 volts gets added to the 5.582 volts, and that gives me 20.75 volts. So across the capacitor, after 2 time constants, I have a value of 20.75 volts. Okay, so third time constant would be V3T. Okay, equals, so then V2T plus brackets V max subtract V2T times 63.2%. Okay, so that's going to be 20.75 plus 24 volts minus 20.75 times 63.2%. Inside of my brackets works out to be 2.04, I think 2.054, okay, and then that's in a bracket, so I apply the 63.2% to it. Hopefully, yep, you can still see that, and that gives me 2.05. Oh, that is that after the 6 point, that's actually 3.25. So 24 volts subtract 20.75 gives me 3.25, okay? And then if I times 3.25 by 63.2%, then that gives me 2.0. Oh, I missed the classroom. Okay, and then I add that, bring down the 20.75, and then I just add the two together, 22.804 volts. So the amount of charge across a capacitor after 3 time constants will be 22.804 volts.